Hello everyone, welcome to my channel. In this video, I'll explain you one more example on Y parameters. Find Y parameters for the network shown in figure. This is the network given to us. Let us write main parameter equations. Y parameter equations are described as I1 equal to Y11V1 plus Y12V2. I2 equal to Y21V1 plus Y22V2. To find y11 and y21, v2 equal to 0. y11 can be written as from the first equation I1 by v1 when v2 equal to 0, and y21 can be written as from second equation I2 by v1 when v2 equal to 0. Next, to find y12 and y22, v1 equal to 0. y12 from the first equation we can write y12 equal to I1 by v2 when v1 equal to 0, and y22 equal to I2 divided by v2 when v1 equal to 0. By using these two conditions, for this case let us redraw one circuit, and for this case let us redraw one circuit and find the values. To find y11 and y21, v2 equal to 0. Let me write here y11 equal to I1 by v1 when v2 equal to 0. So let me redraw the circuit for this. One ohm, 2 ohm, 2 ohm, 4 ohm, and port, this is 1 dash or AA dash, and here we have I2. Condition to be followed here is V2 equal to 0. When you short circuit these two terminals, equivalent resistance for these two resistances will be 0, because when V2 equal to 0, here resistance will be equal to 0. When these two are in parallel, you can see equivalent resistance 0 into 4 divided by 0 plus 4, which is equal to 0 ohm. So this circuit can be replaced like this is how it will become. And the I2 remains same. Okay, this is the equivalent circuit obtained when we put V2 equal to 0. From this circuit we are supposed to find V1 equal to I1 into R equivalent. Okay, so here if you see, I1 current is entering in this branch and it gets divided in these two branches. So we can say these two resistors are in parallel, which is in series with this resistance. So we can write R equivalent as, R equivalent can be written as 2 parallel to 2 plus 1, because these two resistances are in parallel in series with this 1. So 1 plus 2 into 2 divided by 2 plus 2. So 1 plus 4 by 4. 1 plus 1, 2 ohms. If I substitute it here, V1 equal to I1 into 2, and I1 by V1 equal to 1 by 2. Therefore, Y11 equal to 1 by 2, that equal to 0.5 mho. We are done with finding Y11. Next, to find y21. So y21 can be written as I2 by V1 when V2 equal to 0. So we should find the value I2, right? So you have to find how much current is flowing in this branch. Let me call this as some I dash. Okay, so when I1 current is getting divided in this branch and in this branch, I want to just call this as I dash, which is equal to minus I2 because they are flowing in reverse direction, right? According to current divider rule, I can write I dash equal to total current I1 into opposite branch resistance 2 divided by total resistance. Total means 2 plus 2. So we can take it as I1 into 1 by 2 because this is 2 by 4, we'll get 1 by 2. And therefore I2 equal to, because minus I dash, you can write minus I1 by 2. By substituting that value here, we can write this y21 as y21 equal to, in place of I2 I can substitute I1 by 2, by in place of V1 I can substitute this I1 into 2. So this is minus 1 by 4, which is equal to minus 2.5 mho. Y21 value is minus 0.25 mho. So we are done with calculating Y11 and Y21. Let us look at finding other two values. To find Y12 and Y22, V1 equal to 0. We can write here Y22 equal to I2 divided by V2 and V1 equal to 0, and Y12 can be written as I1 by V2 when V1 equal to 0. Let me redraw the circuit for this. This is I1 and condition here is V1 equal to 0. So V1 equal to 0 and this will be I2 and this will be V2. This is the equivalent circuit when you apply V1 equal to 0. Okay, here no resistor is in parallel with this short circuit, so we'll have the kind of circuit like this. Let us find first V2 equal to I2 into R equivalent. According to Ohm's law, V equal to IR, we are applying the same here. V2 equal to I2 into R equivalent. In the circuit, you can see here, this is in one node point, this is another node point where current gets divided. And if you always, while finding equivalent resistance, you should start from extreme end. Here 1 ohm and 2 ohm are in parallel because current gets divided in these two branches, which is in series with 2, and then which is in parallel with 4 ohms because again current gets divided here. So R equivalent can be written as, let us start from extreme end, 1 parallel to 2, which is in series with this 2 ohm plus 2, and again which is in parallel with 4. So this is how you should write it. So 4 parallel to 2 plus 1 parallel to 2 means equivalent resistance is 1 into 2 by 1 plus 2. So we can write 4 parallel to 2 plus 2 by 3. 2 by 3 is 0.6. So 4 parallel to 2.66. 4 into 2.66 by 4 plus 2.66. If you do so, you'll get the answer 1.6 ohm. By substituting this value in this equation, we can write I2 by V2 equal to R equivalent. I2 by V2 equal to 1 by R equivalent, which is equal to 1 by 1.6, which is equal to 0.625 mole. Okay. Next thing is to find y12. To find y12, I1 divided by V2. V2 can be written as I2 into R equivalent, but we should find I1 now. I1 is the current flowing in 1 ohm resistor. In order to find this, we should know first how much current is flowing in 2 ohm resistor. So I just want to redraw the circuit like this is I2 and V2. Okay, I am assuming that here current entering here is I dash and here some other current, because here we have a node point, current gets divided, and I would like to just replace this whole thing like this. So equivalent resistance for this is 1 parallel to 2 plus 2. If I do so, I'll be getting here this as 2.66 ohm, and this is I dash and this remains same. Just I have replaced this 1 ohm, just I have replaced this 1 ohm, 2 ohm and 2 ohm with its equivalent resistance 2.66 ohm, because once I find the current flowing in this branch using current divider rule, then I can easily find I1. So using current divider rule, I can find here I dash equal to total current I2 into opposite branch resistance 4 divided by total resistance 4 plus 2.66. So I'll be getting this as I2 into zero point 0.6. I dash equal to I2 into zero point 0.6. So this I dash again gets divided here as I double dash and this some other current, right? So I can find here I double dash, I double dash equal to, look here carefully, I double dash using current divider, total current, here total current is I dash for us. So I dash into opposite current resistance, opposite current resistance 2 divided by total resistance, that is 2 plus 1, where I dash is equal to I2 into zero point 0.6. And this is 2 by 3 will becomes again zero point 0.6 as well. This will become I2 into 0.396. According to the circuit here, I1 equal to minus I double dash because both are flowing in reverse direction. So you can write here this as minus I1, and by substituting this values here, Y12 equal to, I'm writing here y12 equal to I1 value is minus I2 into 0.396 divided by V2 value is I2 into R equivalent, which is 1.6. So by using calculator you can find this value as minus 0.25 mho. So we have found out y12 value as well. We have got all the values y11, y12, y21 and y22. Y11 we got as 0.5 mho and y12 as minus 0.25 mho, y21 as minus 0.25 mho and y22 as 0.625 mho. These are the y parameters which are obtained for the given circuit, and you can write the main equations as I1 equal to y11 v1 plus y12 plus y12 v2. Y12 we have got minus, so I'll write minus 0.25 v2, and I2 can be written as y21 v1 plus y22 v2. This is how we can write main equations. That's all for this video. Thank you.